Avenue Radio.
Do you want to reach out to the Vietnamese community in Seattle? Just advertise in Le Viet Tây Bắc, that is Northwest Vietnamese News, the longest running Vietnamese language newspaper in our region. Go to nvnorthwest.com.
Rainier Avenue Radio presents All Music, All Day Saturday. Music, All Day Saturday.
This is Edwin Bailey, Bulldog Blue.
Jazz from the Cabinets.
That's right. It's time once again for Jazz from the Cabinets with Big Poppy.
Start Time.
Thanks for tuning in. My name is Paul Pierce.
This is Start Time. Saturdays, all music, all day. Reggae Hour. K-Fox Night.
Looking for the perfect beat? Yeah, it's the beat of the box.
Fresh Juice with D-Money in the group.
Myself, D-Money.
Nice Size Patrol.
Taylor Hart.
This is Spencia, the Northwest Rap Game.
DJ Medina. Chad Cheddar. Northwest Rap Game.
Sergio Lacour's Love Line.
It's Sergio's Love Lines with Sergio LaCour. Go to the phone line. Tell them who we
Sea Monster Radio. Mo Jams is your jam.
We're live. Welcome to Mojo Mondays. This is KZ of KZ Music Media. Caller Goddess for Mojo Mondays.
Just my opinion. God is inspiration all day and all night. Saturdays on RainierAvenueRadio.org.
This is your Rainier Avenue Radio.world community update on the new City of Seattle Community Resource Hub, a one-stop online shop for city resources and information. Supported by the Seattle Department of Neighborhoods, the Community Resource Hub can be found at seattle.gov/resource hub. It's an online portal of city resources, information, and tools to help community members connect and engage with city government and with each other. That is seattle.gov/resource hub.
This is Mondo Bancaro for Mondo's World. We will be discussing some interesting subjects. Sometimes I might even have some guests. So please listen to my show on Rainier Avenue Radio.
Metro League High School Football is back.
He tackles off to the races. He could go all the way. He could go. Touchdown.
The return of Metro League High School Football, Friday and Saturday nights on Rainier Avenue Radio.
Makes a stutter step inside, breaks a tackle. He's on the way. He's going to take it all the way. He's going to take it all the way on the sideline.
Exciting Metro League football live on Rainier Avenue Radio.world. It's back.
This is Paul Pearson, host of Star Time. And when I'm not translating the lyrics of Boogie Oogie Oogie for bored Europeans, I'm listening to Rainier Avenue Radio.world.
Welcome to Rainier Avenue Radio. This is Afternoons with Monique, recording live in Seattle, Washington, every Thursday at 1 p.m. Good afternoon, Seattle. This is Monique Lee from the Afternoons with Monique show. You are on Rainier Avenue Radio. Today, I have the pleasure of inviting one of my friends, Matthew Scholz, who is CEO and founder for Oisin Biotechnologies, as well as a co-founder for 5 other biotechnology companies where he had raised tens of millions of dollars in investment capital and grants. Please welcome to my show, Matthew Scholz.
Thank you, Monique. Great to be here.
Wow, I haven't seen you in a minute, huh?
I know, it's been too long.
Everybody's getting a little gray right here. I haven't seen you that long. Oh my gosh.
I'm hard at work at solving that problem as well.
Right, we're gonna learn about aging and reversal of aging and some of your technology today. I'm very excited, and the audience, I'm sure, would love to learn how biotechnologies can change people's lives. So Matthew has spent the last 13 years melding computer science and biology in Seattle. So he's like the math scientist that I know, the local math scientist that I know, and I have the pleasure of having you here. Why don't we start with sharing with our audience a little bit about your background? How were you born and raised in the United States, and where did you grow up?
Yeah, well, I was actually born right down the road in Kent. So I'm a Pacific Northwest native. I grew up in Vancouver, Washington, though, so near Portland, Oregon. And I returned to Seattle to go to the University of Washington, and I basically stuck around. So I suppose before COVID times, I would be traveling, 3 weeks out of the month. But these days, I'm around a little more.
Right. I see you popping in and out of town. Catch you with some glimpse at the CTC occasionally and through some of our common friends. So it's always great to see you, sharing some of the wonderful things that you're working on. So I'm excited to learn your integral role in the development of advanced therapeutics, first-in-class treatment modality. So some of these terminologies I am unfamiliar with, and I'm sure the audience would love to know some of the things that your companies actually, and you are developing. So you went to the UW. What did you study there?
I studied computer science primarily, and some physics as well, but I didn't actually get a degree in it.
Right. And I think you, in the last 13 years, you started several startups and raised a lot of capitals for these startups. Can you share with our audience some of the names and the work that you've done in the last 13 years?
Yeah, well, so I had spent, my life writing code, basically. I started programming when I was 8 years old and had done that for quite a long time. And so even as I left the university, I was doing still computer type stuff. So GPS-based fleet logistics, the company called Point D Telematics. And I did a bunch of kind of cybersecurity and mobile application development, and had sold my last tech company and got interested in bio. And what really led me into the North Star for me was that the essence of life is information. And if you can manipulate information in life, you can do anything with it. And this, what it actually initially captured my imagination were vaccines. And that if you get a vaccine, a disease that used to kill you won't even give you the sniffles. And you take smallpox, it's a notorious one. And but if you think about it for a moment, nothing's fundamentally changed about the pathogen or the host. But suddenly you're immune. And we pay lip service to this idea of immune system memory, but the computer scientist in me wanted to know, well, where's the file? Where's the hard drive? And what language is that written? And that kind of led me down to manipulating those things.
The codes. So, occasionally I read these articles on different magazine about gene editing, and, now you work in this field of what is called immunoprophylaxis. A mouthful there.
There's a lot of gibberish in this field for sure.
Yeah, vector immunoprophylaxis, lots of syllables.
Yeah.
For HIV and Ebola, as well as COVID-19 vaccine. Tell us about this. First of all, what is gene editing? Just in general, remind us what that is.
Yeah. Well, gene editing is basically what it sounds like. It's changing a part of your genome. As it applies to the stuff we've been working on, though, my first biotech was Immusoft, and we were building, what we kind of described as an app store for the human body. Instead of making a treatment and injecting it, we'd program the patient cells to make their own treatment. And specifically, we programmed a kind of immune cell, a long-lived plasma cell. They normally make antibodies. But when we started doing that, there were no approved gene therapies or cell therapies. I mean, this was way before CRISPR existed and that kind of thing. And so the tools we were using to modify DNA were different. And so when people say gene editing today, they're typically referring to things that change a specific part of the genome. But that's not the only way to manipulate the genome. I mean, you can insert DNA kind of randomly, like a lentivirus does, or you could put DNA into the cell or into the nucleus, but not into your actual chromosomes. And it behaves a little bit like a computer program that's in RAM memory as opposed to written to the hard drive.
I have a question, Professor. Okay, how do you modify a gene? I mean, is it through injection? You put some chemical in your body and it modify the DNA code, but that's within individual cells. How do you edit something that is already born and raised and fully developed?
Yes, I mean, it's a great question. Your body, of course, has a vested interest in not letting people or things mess with your genome. It tends to be bad for its health. And there's one, I guess, obvious thing that everyone's familiar with, and that's viruses. And a virus is basically like, a thumb drive that can walk, right? It's a little computer program in a shell, and it can insert it. It can get it into the cell and get the payload delivered to the correct place, all with one machine.
Right.
But and we certainly use those in my field a lot, but it's not what I do specifically. And so if you think of these really common now cancer treatments you get a lot of news, CAR T-cell therapies, those all take the cell out of your body to where it's kind of more defenseless, and then they modify it outside of the body and put it back. And so it never changes all of your cells, only some of them. And as a general rule, any kind of therapy that you might give to an adult is never going to change all of their cells. It's only going to change some of them. And if you wanted to modify all the cells, you need to start from an embryo, basically. And people do this all the time with mice, for example, and genetically engineer mice, but you don't do that with people, or you shouldn't. The Chinese do, notoriously.
Is that a question of ethics, or is that why not?
Well, it's certainly an ethical issue. Like it's outright banned in most places in the world, but because there's this risk, of course, that you can cause, immeasurable amounts of harm to someone who hasn't been born, and that it can, of course, escape into the population. But so there's definitely issues like that, but there are also technical issues, and that with mice, say it takes you a few tries to get it right. It's much people cry less about dead mice than they would dead humans, and so there's practical aspect of it that limits it, and just both technical and ethical limitations.
Right.
It's generally not done.
So the last time we had a human subject was I believe around 1945, Hitler and his Nazi friends, right?
Well, I mean, the last recently documented ones, the Chinese CRISPR'd a baby, and they knocked out a gene called CCR5 that was supposed to make it resistant to HIV. It was what they claimed, and that was only a couple of years ago. But it also, interestingly enough, is a gene that when you knock it out is associated with increased intelligence. So I suspect there's probably more. There are easier ways to protect a young baby from HIV than changing its genome.
Interesting. How fascinating. What a great field you're in.
It is interesting. I mean, I think this is it keeps me up for sure, but it's this, exciting space where there's a lot of unknown, but we've gained tools even in the last decade or so that never existed before. And it's growing at a rate that's hard to keep up with.
Right. So you've started quite a few companies here. I think initially you had Point B Telematics, and then you were a chief executive officer for that. And High Bio Community Lab, you were co-founder and on the board of directors for Sigma Genetics for at least 5 years, and your baby ImmuSoft, which you started about 13 years ago, in various roles, but mostly that was, I believe, that's your baby in this biogenetics field. Can you tell us what ImmuSoft, and I'll ask you about the two recent or present companies that you are also currently running, because we like to know all these fascinating technologies that you are developing, and where you hope for them to do for the population, our humanity. So can you tell us what ImmuSoft Corporation, what does it do?
Yeah, so basically it's the one that's the app store for the human body. And
Right.
so more technically speaking, it produces autologous long-lived plasma cells that secrete therapeutics. And we got started, so its core technology is a mix from some technology out of Caltech, developed by a guy named David Baltimore. He's a Nobel laureate immunologist, virologist there. And then some technology from a school called ENS Lyon in France. And we basically built the ability to effectively kind of hijack cells that normally make antibodies in your body and get them to produce other things. So
Right.
in some respects, we made custom antibodies, like broadly neutralizing HIV antibodies. And its first treatment that's going to the clinic actually makes an enzyme called IDOA, alpha L-iduronidase, to treat a rare genetic disease that affects children. And so if children are born with this, they can't make an enzyme. They need to break down certain kinds of sugars in their cells, and they effectively melt down from birth. It's lethal, usually by 10 or 13 years of age if you don't treat it. And if they get, stem cell transplants and kind of the best care, usually they make it into their 20s, but it's really nasty. And so we're basically repurposing the immune system to make lots of this enzyme for them. And
Interesting.
the goal, I suppose, long-term for me when I started, and this kind of is what links the first company to the later ones, is that I wanted to recreate the biochemical environment of youth as you aged. And if you think about it, you could take your blood, once a year from birth until death, and it's not the same. Things change. Like you can think of obvious things like, say, estrogen or testosterone, but countless other things change as well. And you can never take enough drugs to fix it. You never put it back to the way it was. But if you can manipulate the code of life in these cells, you could, in theory, produce all sorts of stuff that would be impractical otherwise. And so that was kind of my goal in being able to manipulate these systems.
Right. So this app that you guys were developing, did you ever come up with the app? And is it for everybody to download and use and monitor their own immune system and genetics, or what is it?
Well, it's an app in some respects, the figurative sense, but consider that, your genetic code is basically a programming language. It's like a base 4 assembly language. And it sounds weird, but you can type a gene sequence into your web browser and it will show up in the mail in a FedEx envelope. You can quite literally write an app in the code of life and get it produced into tangible DNA. And so what ImmuSoft does, or its core competency, is taking those apps and putting them into your body. So it's like a brokering of information into life. And so it's not it of course has made some apps, like whether it be antibodies or enzymes and tools to build muscle and all sorts of other fun stuff. But its specialty is really getting those things into you.
Very, very interesting stuff. I mean, we could go on and on about all of this technology. And when I chatted with you last, I asked you, what is it that you developed, Matthew? And you said, I work on changing longevity or something like that, reversing the effect of time genetically or something like that. And I find that to be very fascinating. So the two current companies that you are actually, I think ImmuSoft is still existing right now.
Oh,
right?
yeah. It's still very much alive. I'm on the board of directors now, though. I'm just not involved in its day-to-day operations.
Right.
No longer CEO.
Oh, okay. But now you are running Oisin. I hope I pronounced that correctly.
Oisin,
like a SH?
Yeah, so it's actually the same spelling as the Gaelic version of Kathleen. So the IN is pronounced EEN in American English. But it's actually the name of a person, which is.
Oh, okay. In Irish culture or something like that?
It's a Gaelic myth. He is a warrior bard who journeyed to the land of eternal youth. And so the company is named after the story.
Oh, okay. There's some mythology that origin. Okay. And so Oisin had been in existence for about 7 years, 8 months.
Yeah.
And tell us, what does Oisin Biotechnologies do?
Well, so our kind of broad mandate is to ameliorate the diseases of age, to improve health and longevity. And in long term, we want to extend in lifespan and health span. But it's interesting, if you pose the question to somebody, say, hey, who wants to live to be 200? Almost no one says yes, because all they can think about is being a 100-year-old for another 100 years. And but if you made a person immortal, for example, you could correct all the problems. They'd be 30 forever, not 100 forever. And so, I would say for a while, the goal is to live in perfect health for 1,000 years. But kind of maybe more practically, it's to die a young, violent death at 150. Like, I crashed my motorcycle because, I'm flying down the highway doing, 200 miles an hour when I'm 150 years old. And oops. And so to basically, and so if you look at like the studies we've done and the treatments we've built and how we test them in animals, you see these animals that they live in good health for longer. So most of the pathologies of age, the frailty and decay that we associate with growing old, doesn't occur, or it's attenuated. So basically the period of morbidity is compressed. So they live in good health and then they die abruptly older than they normally would. And that's, I think, the first step is to basically maintain your good health longer. And in that respect, living longer becomes a side effect. That if you aren't getting sick and dying, you live longer.
That's fascinating. I've seen this movie called The Age of Adeline, where there's a young woman who, have you seen that movie?
No.
Oh, you definitely need to see it. What's her name? Blake Lively was the main character, and she's, of course, gorgeous. So, I just like to watch her fashion in that movie. Yeah, and basically what it is she got into a freak accident, car accident, and she was shot by lightning, and then it somehow modified her genetic code that she stay young, like at that age for the next 100 years, or 50 years or something like that. So she would have she didn't have children, but her mom she did have a child, and then her child started looking older than her. So the child pretend to be her mother and then her grandmother, and she keep getting, scientists keep trying to capture her and study her. So she has to go into hiding. and anyway,
I'll totally watch that. It sounds
it sounds like it's relating to your
Benjamin Button or
Reversal of Age.
Interview with the Vampire. There's a long history of it. People have thought about this a lot.
Immortality is the dream of ours. No.
Yeah, well, I guess it's to be young forever, not to simply live forever. You want to be like the curse of becoming frail.
This funny observation that I'm gonna run by you. So my grandmother, maternal grandmother, lived to be 103 or so, 104, and when she passed, she has 10 children. And back in the day, she didn't work; her children were her job. So and my mother is probably gonna beat her because she looked exactly like my grandmother, and I unfortunately don't look anything like them, so I'm not gonna get to live 100 plus. But what is interesting is my grandmother moves really slowly. As long as I could remember my grandmother, she tended to move rather slowly, and but she'd read the newspapers until she was 80s. So she's very sharp and very intelligent Asian lady. They live in Asia, obviously. And, condition of living is not like prime or optimal, but, she get to live to be 103 or so. So I'm like, maybe moving slowly like a turtle. Hey, I can make a comparison that a turtle and all the slow moving animals live a long time. So does that mean that if we slow down, we would live longer?
Well, there is like a ridiculous amount of academic research that goes into trying to understand what is age and what drives it. And certainly like a tree doesn't move at all and they can live very long. But not all trees, but some trees. Although you also have things like, say, the bowhead whale, which lives a couple hundred years, and it's enormous.
They're very large.
It's huge. And I mean, in some respects, you think the bigger you get, the more opportunity for, say, cell division and cancer and stuff like that. So to be really big and long-lived, you have to have some pretty impressive DNA repair machinery and be able to mitigate this damage. And these creatures, make an elephant look small, and they live for. I mean, there are bowhead whales swimming around now with wooden harpoons lodged in them from the time of Moby Dick. And so they went from being like, chased with wooden harpoons to like, atomic bombs going off in the ocean to like all sorts of this craziness. And they're still out there swimming around. And this is, captivated the interest of a lot of people. Or, I mean, what makes it live so long? And I mean, or you can take things like a normal mouse versus like, say a naked mole rat. One lives 3 years, the other lives 30. They look pretty similar. They, in those cases, I think they probably move pretty similar. But in general, I suppose if you're really like a hummingbird, they don't live forever. So.
Moving too fast.
It lives on sugar and moves around. But I don't know. If you compare, I generally don't spend much time thinking about stuff like a turtle because it's so different from a human. So I'm interested in more mammals and ideally large mammals and primates. And it turns out humans are pretty darn long-lived for, especially if you consider the abuse we like to put ourselves through.
Oh, right. All the smoking and drinking that people do.
Yeah. I mean, we outlive, the majority of creatures on the planet, really. And a lot of the ones that are either, biologically immortal or very long lived don't have nearly our metabolic requirements or activity level. And so it is an interesting observation that if you move around fast, maybe you get yourself killed earlier.
Accident prone.
I don't know. I suspect it doesn't affect variation in humans very much, but it's interesting in a broader sense.
It's an interesting observation. Also, the size of the mammals. I feel like, like you said, the larger, those turtles that live to be 300 years old, they're huge. They're gigantic. But they also have a house on top so they can hide.
It might keep them from being eaten. It's harder to eat a giant turtle than a small turtle.
Right. So, very fascinating topic. Now, tell us the second company that you also running. Let me see what it's called. It's called OncoSenX. And you just started that like about 3 years ago. What does that company do?
Yeah, so OncoSenX actually spun out of Oisin. It's a joint venture between Oisin and a company called Entos. And I suppose to understand what it's up to, it makes sense to know what Oisin was up to. And so Oisin started building something called a senolytic, basically a tool to kill damaged cells in the body. And the general idea here is that the reason you get a wrinkle isn't because your body forgot how to make collagen. It still has the same genetic instructions, it still knows what it's doing. I mean, you have basically the same genome when you're 7 as you do when you're 70, but you look a lot worse when you're 70. And so that's like what's going on here. And one of the drivers of a lot of the pathologies of age are the accumulation of a kind of damaged cell called a senescent cell. And you can think of them in some respects like a zombie. And normally if a cell gets damaged, it either fixes itself or it gets killed or kills itself. But it's possible to damage them in a way that they don't die and they can't fix themselves. And they sit there secreting these inflammatory cytokines, these molecules that generally poison their neighborhood and notably impair stem cells' ability to regenerate. And so a few years back, some guys at the Buck in the Mayo Clinic did a study where they genetically modified mice so they could get rid of those cells. And then they started treating them either when they were young or when they're kind of upper middle age. And the results were pretty amazing. If you treated them from when they're young, most of the diseases of age never manifest themselves at all. They looked young until they died, or greatly at least attenuated them. And they also live longer. And so the problem with it is you can't go back in time and modify your own embryo. So what we built was a tool to do this that would be viable clinically. And it brings about a kind of a special problem. Like if you think of cancer, where the standard of care is eating poison, like there's huge tolerance for damage, collateral damage. Like no one who's gone through chemo and radiation says it's a blast, right? Like it's terrible. But for aging, no one's going to let you take chemo to try to kill a damaged cell. And so we wanted to build a tool that would kill one damaged cell surrounded by an ocean of healthy cells with no collateral damage. And the only way to do that is to basically not use a poison at all. to have no drug. And so we wrote a computer program in DNA that says, if you're damaged, kill yourself. And you basically inject this into your veins, and it goes all over. And it'll go into healthy cells and the senescent cells, but it only turns on in the senescent cells. So that cell commits suicide, self-destructs in the middle of it, and leaves everything else unharmed. And so that was the first thing Oisin built. But it occurred to us pretty early on that you could probably use it for cancer also, because there's a lot of genetic overlap between aging and cancer. And so we did some early experiments with this. And actually, one of our board members had a friend who was dying of cancer, and we'd been talking about this idea for a while. And he's like, I tell you what, I'll give you 50 grand if you just do the experiment. I'll just pay for it as a grant. Let's just see if it works in cancer. So we did it, and the results were astounding. It was 90% reduction in tumor burden from a single treatment. It's
really?
Melted away, and it's in mice, of course, not human, but it was striking, very striking. And so we knew that we should do something with it, but we didn't want the aging company to become a cancer company, and so we basically spun it out as its own entity. So OncoSenX builds tools for cancer using this platform. And you remember at the beginning, Immusoft was building app stores for the human body, but we took the cells out, put them back. With this, we're injecting programs into your body, and they're changing things in place. And they're not necessarily making things, sometimes they're killing things, but they're a way of basically altering the code or manipulating the gene expression in cells across the body.
So basically self-employ all these damaged genes. How fascinating. So thank you, Matthew, for coming on my show and sharing with our audience and me the important work that you do in the field of biogenetics and bioimmunology, helping our community, our society, our humanity live better lives. So we're out of time. Thank you once again for joining me. You're on Afternoons with Monique. Have a good afternoon, everyone. Thank you.
Thank you.
This is Paul Pearson.